Okay, YouTube, in our last couple of videos, we've been exploring binomial expansions or binomials to a power. And in our last video specifically, we looked at this giant mess right here, but we call this our binomial theorem. And it says basically, in general, any x plus y to the n can be expressed in a convenient manner in this way, where every term that we're adding together in this expansion basically has binomial coefficient that is a combination, n choose r, where n is the power we're raising this thing to, is the power. Okay, and we see that we have basically two other things here, x and y, from our binomial that have a trade-off of powers going on as we go across our sums. So we're just going to take a look at a couple of sums here. I'm going to show you how I would piece it together very, very quickly using the binomial theorem. But basically, what I would say is this: writing the binomial expansion of something like 2x minus 3 to the 4th. So the first thing is this: 1. We're going to write as a sum. Write at, oh, that looks ugly, as a sum first. And the reason why is because this is a summation here that we're doing. So we need to write 2x plus a negative 3 to the 4th. And what I'm going to do is I'm going to list out our things here. Now, in our binomial theorem, I hate to point this out here, it uses, instead of a and b like I'm going to use here, it uses x and y right here. You could see how easily we could replace that with just an a and a b. And the only reason I say I'm going to replace it with a and a b in this particular instance is because we're already using x as one of our values here. So for our first thing here and our second thing to the power of the nth thing, if I were to say this is some a plus b to the nth power, the first thing in our binomial here, I'm going to write this down first, is a is 2x. And our second thing in the binomial is negative 3. And then our power that we're raising this to is the 4th power. And you just kind of keep track of these things right here. So in our expansion, here's the fun part of this. We're going to go straight across. We're going to say coefficient, first term, second term. And what I'm going to write here is this. In our binomial theorem, it states that with our power being 4, that the first term in our expansion here is going to start with all the power 4, and that the second term in our binomial here started with none of it. So what we're going to get is this, plus now coefficient, first term, second term, where this is now 3 and this is 1. So plus, I'm going to try to write a little bit smaller here. Coefficient, we have first term, second term to the 2 and to the 2, plus coefficient, first term, second term. I'm not going to make it, you guys. We say 1 and 3, plus, oh man, hey, forgive me. I'm going to write this plus right here. Plus, oh geez, we'd say 0 and 4. Okay, so here's our expansion here. But what I want you to notice first is essentially this. We have coefficients in front that we haven't determined yet. That's not bothering me. But that our terms, basically, we recognize that the power is 4 and that we see that all of these exponents, if you add them up, they all add up to 4. Every single term in our expansion here has exponents that add up to 4. And also this, that our 4 starts on the first term here. I mean that this first factor in our term here that we're multiplying by, starts with all of that power, and as we go left to right, it loses it. 4, 3, 2, 1, 0, whereas the second term gains it 0, 1, 2, 3, 4. So now all we have to do is determine our coefficients, okay? So I guess we could start with that. Let's look at Pascal's triangle, which is 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. I suppose we could do one more. 1, 5, 10, 10, 5, and 1. And this goes on forever and ever. But basically, what I recognize is that I have 1, 2, 3, 4, 5 terms here. So 5 terms would indicate to me that I'm using this entry right here in Pascal's triangle because, well, it's got 5 terms in it. Now, the other thing I recognize is this. The first row here is, we say what we get when we raise something to the 0 power. So first row is 0th row, really. 0th power, first power, second power, third power, fourth power. And we were raising this to the 4th power here. And so we would use this. We would say 1, 4, 6, 4, and 1. So the last thing we're going to do is we're just going to fill in everything here. Here's the fun part. We say 2x, 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 and then our second entry here is negative 3, negative 3, negative 3, negative 3, negative 3. And you get this. And so congratulations. If you can write it this way, this is the correct answer. It's just that we need to simplify it. So in every instance, we're going to need to simplify something like this. So let's go ahead and start with this. 1 is 1. Negative 3 to the 0, well, that's just a 1. And so we really get 2x to the 4th, which is 2 to the 4th is 16. X to the 4th is x to the 4th. So now our next term, we get 4. And now 2x to the third times negative 3 to the first. So I'm going to take my time here. I'm going to say this is 4 times 8x cubed times negative 3. So it's definitely going to be a negative thing. 4 times 8 is 32, and 32 times 3 is 96. So I get 96x to the third. So now moving on, we get 6 times 2x to the second, which is 4x squared. Negative 3 squared is a positive 9, so we get a positive thing here. So we get 6 times 4 is 24, and 24 times 9 is 180 plus 36 is 216. Sorry to do that really quickly there. And then we also had an x to the second on that. And we say, okay, so now 4 times 2x, so we get 4 times 2x to the first, which is 4 times 2x, times negative 3 to the third, which is negative 27. This is not going to be a fun one. It's negative, and we have a calculator here, so we can use it. But we say 4 times 2, which is 8, and then times 27. So we say times 27. We get 216 as well, so we say 216, and that has an x to the first on it. And then we'd say our final term here was this 1 times 2x to the 0, which is 1, times negative 3 to the fourth, which is 81, and that's positive 81. So I'm going to put a big box around this. I'm going to say this is our expansion right here. So believe it or not, doing this to the fourth power the long way is actually longer than doing the expansion once you get the hang of this. So speaking of getting the hang of it, let's try this again here. And it might behoove you to pause the video and try this one on your own before we start up. But I'm going to say that here's what we have. Our first term here, if I can write on this here, breeze through this one. We say a, our a-like thing is our x squared, and our b-like thing is our 4, and we're taking this to the power of 3. So tracking these things right here, what we know we're going to get is this: coefficient first term, second term, plus coefficient first term, second. I just like to fill in a few of these at first. Honestly, I should write smaller, but here's what I do know. At least, since we're taking it to the third, this is going to start with a 3 and a 0, and this would become a 2 and a 1, and this would become a 1 and a 2. And I can just verify visually here that I only need to go one more term. This is going to be a 0 and a 3. So all of our exponents add up to 3. I also know this, that all of these coefficients in front can be obtained with Pascal's triangle. So now, given that we need 4 terms here, 4 terms I can count, going back to my triangle that I drew on the other page here, I can see that this is the row having 4 terms. So it's 1, 3, 3, 1 are our coefficients. So I'm going to fill these in as well. 1, 3, 3, 1. In terms of what we get on the insides here, our first term here, our a-like thing is x squared. So we'll fill in an x squared in each one of these first factor entries, and then we'll fill in a 4 in the second part. So taking our time, seriously, you do want to take your time on this. We get 1 times x squared to the third, which is x to the 6th, and then we say 4 to the 0, which is just 1. So we get x to the 6th plus now 3 times x squared squared, which is x to the 4th, times 4, plus now 3x to the second to the first, which is 3x squared, times 4 squared, which is 16 there, plus now this is a 1, this is a 1, and we get 4 to the third, which is 64. So going back and cleaning this up one more time, we get x to the 6th, plus now 3 times 4 is 12, x to the 4th, plus 3 16ths is 48, x to the 2nd, and then 64 constants. And this would be our binomial expansion right here. So in this next video, we're going to look at how we can really just single out particular terms of an expansion. Cheers.